Here's problem 6.1. A race car travels 40 meters per second around a banked 45-degree with a horizontal, circular radius of 0.2 kilometers track. What's the magnitude of the resultant force on the 80-kilogram driver of this car? Let's try and imagine what we got here. We've got an embankment at 45 degrees, and on this embankment is a car. And the radius of curvature, as this car is going around this embankment from some middle of a circle, is 200 meters. So R is 200 meters, going around some kind of circle as we're looking at it this way. And if we were to do a free body diagram on the car, and especially the driver, we would have a force going down like this, equal to the weight of the driver, mg. And then there would be a normal force of the seat acting normal to this embankment. Let's call that n. And that normal force could be broken up into two components. One component that is offsetting gravity this way, and another component that is inward on the circle that way. This angle here also being 45 degrees because the normal force is perpendicular to the embankment, and that component is perpendicular to the ground. So we would have a component of the normal force in cosine 45 degrees, which is offsetting the weight, and then we'd have an n sine 45 degrees, which is inward on the circle. So ultimately, as far as the circle is concerned, we have 200 meter radius, and then we have a force that is inward called n sine theta, n sine 45 degrees, and that force is supplying our only center-seeking force, so that force is supplying our centripetal force. So the way we would write it, at least in the direction of positive acceleration, which is also inward, is we would say the summation of all the forces is equal to mass times acceleration, and that would be equal to the inward force, which would be the normal force sine 45 degrees. Well, the acceleration in this case is centripetal, so it's going to be mass times velocity squared equals n sine 45 degrees. We could go on to solve this, but notice one thing about the way this problem is stated. It says, what is the magnitude of the resultant force? Well, the resultant force is the net force, and the net force is either this total force here or the MA. MA is your net force. So in this case, that's our resultant force, and we really didn't have to go and set this up the way we have. We just need the resultant force, the net force. So our net force is indeed just the mass times the velocity squared over r, and in this case that would be the 80 kilograms for the driver, moving at covered it up, moving at 40 meters per second squared over a radius of 200 meters, and that gives us what? 80 times 40 squared divided by 200, 640 newtons. So our net force, our resultant force, is 640 newtons inward to the center of the circle.